Okay, so here's what you should have found out in this lab. So if you need a recap or if you missed it. Okay, so you have a velocity versus time graph, and it should have come out to be a line, all right? And your y-intercept should be at 0, 0, and your slope should be 10 meters per second, roughly, somewhere around there, okay? The actual value is more like 9.8, and this one probably came out pretty clean because it's a simulation. Or if you use real data, it might come out a little bit more rough. But anyway, it should be around 10 meters per second. That's a value that we use just to make the calculations a little bit easier, which is fine and accepted to do that even, for example, on the AP Physics test. Okay. All right. So the name of this special acceleration value is called the acceleration due to gravity. Okay. So you never just want to say the word gravity. You want to say the acceleration due to gravity. So this is the rate at which the Earth, right, would pull all objects to it, okay? And it doesn't matter if the object is big or small, heavy or light, the Earth pulls at the same rate, okay? It doesn't pull the same hardness, right? It doesn't pull the same amount, which we'll talk about a little later, but they will accelerate at the same rate, okay? So everything would kind of fall together. Okay, assuming we're ignoring any air resistance, any friction with the air, any kind of like parachute, wings, motors, none of that. If it's just in what we call free fall, meaning only under the influence of the Earth's pull, only. Okay, all right, so that is acceleration due to gravity, and that has a special symbol, which is called G. Sorry, my parents' phone is ringing, and I don't know how to answer it. And I'm not starting the video over again for the 5th time, so you'll have to just live with it. Okay. It should end in a minute. Maybe. Oh my gosh. I know. I'm sorry. I can't start the video over again. I just can't. I've already done like 5 times. Okay. There it goes. Okay. All right. So the symbol for the acceleration due to gravity is a little lowercase g. Okay. And so we would say G is 10 meters per second, and it always acts downward, right? Because the Earth always pulls things down. And in our cases, for the most part, we're just going to set our downward direction to be positive, okay? So like when we're making a graph like this, we would get a positive 10 meters per second. And if we had like a picture of it, right, down would be our positive direction, okay? Just like when we do X direction stuff, we usually say to the right is positive, okay? So we're going to say down is positive just to keep the math a little bit easier, all right? Okay. All right, so the value of the acceleration I've already said is 10 meters per second, and this is for something near the surface of the Earth, right? So this is a value that will come out if you're close to the surface of the Earth, and close even means like, you know, at the top of Mount Everest. That is still considered close, okay? It's still roughly the same number, little bit less, even if you're that high, okay? When it's not the same is if you're like in a satellite very far from the planet, or like on the moon or on Jupiter or somewhere else, it would not be the same value, okay? All right, you don't really need to know this, but just for interest purposes, okay? This number, acceleration due to gravity, is based on the planet itself, or the large object to which something is drawn, okay? And it is based sort of on the mass and the radius of the planet, okay? Mostly on the mass. The radius is involved too, okay? And depending on if it's a bigger, heavier object, like Jupiter, for example, its acceleration due to gravity is around 27, okay? And the moon, right, is around 1.6. All right. And that's because the moon is much less massive than the Earth and much smaller. All right. So that's, if you've ever seen like moon videos and the astronauts are kind of walking around bouncing, it's because there's not as much pull from the moon to pull them down. Okay. But for our purposes in this class, all we really care about, we're only going to be talking about near the surface of the Earth. So we can assume that G is always going to be 10 meters per second in a downward direction, which for us, we're going to call positive. Okay. All right. So after this, you're going to go ahead and work some of these problems. Okay. And the only difference between this and what we just finished is if it's an object in free fall, the acceleration is always 10, right? That is like a given thing that's not stated specifically in the problem. all right? But that you just have to know is a given thing that the acceleration is going to be 10, and we're always going to say that the downward direction is positive, all right? And then I'll make an answer key for the problems.